Hey guys, Coach Moss here. So this is 4.3 over solving exponential equations. I like solving exponential equations. I think you guys will as well. I believe you've done stuff like this in the past, but if not, it's a pretty simple concept overall. You're going to see two different types when solving exponential equations. The first one is going to be the more simple one to solve. You will just need to adjust bases, but on type 2, you're going to have to use logarithms. So let's go over the first one. And what I mean by adjust bases is I'm talking about the 2 and the 32. So 2 to some power plus 6 is equal to 32. Luckily, 2, if we put it to a certain power, it does equal 32. Now, you can kind of just guess and check and solve this one. But when we are doing this, we'll change the base of 32 to where it equals 2 to some power. To the 5th power is actually what 32 is going to be. And you'll just make them match. And then once they match, we can basically act as if the bases aren't there. So then it's x plus 6 is equal to 5. Subtract 6, and then x is equal to -1. And this makes sense because if it were a -1, it'd be 2 to the 5th equals 2 to the 5th, which it does. Let's move on to this one. So here we have a base of 9, and here we have a base of 27. Now, we cannot change 27 to match with a 9 base because 9 squared is 81. So there's nothing that we could change 9 to, or 27 to as far as 9s go to make the exponents match. But what they both have in common is 3. Because 3 squared equals 9 and 3 cubed equals 27. So we are going to change both of our bases to where they have 3 in the base. So because we already have a 2x minus 1, I will be putting 3 to the 2, but in parentheses, I'm going to put 2x minus 1 because when you multiply exponents by exponents, you have to multiply them by each other. So we have 3 cubed over here. So all I've done is just change the way that it's written. All right, from here, I'm going to distribute, and I'm just going to act like the bases aren't there. So we have 4x minus 2 equals 3. I'm going to add this 2. I have 4x is equal to 5. I'll divide by 4, and my x is equal to 5/4. All right, let's move on to some that are a little bit more difficult with the logs. All right, because we have 5 and we have 18, there's no way that we could make these bases match at all. They have nothing in common. So what we're going to do is we're going to take this exponent and move it to the front and write it in log form. So we have 2x minus 3. And this will be the process each time. You'll take the exponent, move it to the front, and put log of the base is equal to log of 18. Now, you have to use your calculator when you are working with logs. If you were to go and calculate log of 5, it would be 0.699, around there. I'm going to keep this in parentheses, 2x minus 3. And then you could also do log of 18, and you would get 1.255. I've already done this math, and that's why I'm just going ahead and writing it out. So I'm going to distribute this 0.699 to both of the terms in parentheses. Once we do that, we'd get like 1.398 x minus 2.097 is equal to 1.255. Obviously, we're working with some pretty wild looking decimals, but that's okay. That's going to happen when you're doing logs. 97. I will add the 2.097, and you'll still solve the same way, even if these were just whole numbers. 1.398x is equal to 2.097. We will divide these, 1.398, 1.398, and we'll definitely be rounding these probably to the thousandths place, always. take my eraser off. Leave that off. Get somewhere around 2.398, 2.4, somewhere in there. All right, let's look at these ones down here. Luckily, 3 and 81 share a lot in common. We're going to keep the base of 3 here. 81, if we were to just write that over to the side, is equal 3 to the 4th power. So we're going to go ahead and change that. 3 to the 4th power, but we still have 2x minus 1 is equal to 3 to the x plus 2. From here, I can act like my bases aren't there. I have x plus 2 is equal to, and I'm going to go ahead and distribute and kind of skip a step, 8x minus 4. All right, I'm going to move this x over here, and I'm going to move that 4 to the other side. We have 7x is equal to 6, divide by 7, and then our x is equal to 6 over 7. All right, if you want, take a moment to pause the video here and work this problem, and then, start it when you want to just check and see that you're on the right page. We'll have to convert both of these to a base of 2. 4 is equal to 2 squared, and 8 is equal to 2 cubed. I'm going to zoom out a little bit so it doesn't get blurry. All right, so then we have 2 to the 2nd power times x minus 1, and then we have 2 to the 3rd power times 2x plus 3. All right, I'm going to go ahead and distribute and get rid of my bases at the same time. So I have 2x minus 2 is equal to 6x plus 9. All right, from here, I will move my 2x over. Let's see, we have 4x, and I'll move my 9 over as well. Is equal to negative 11 divided by 4. X is equal to negative 11 over 4. All right, let's move to the next side. We've got a couple more examples that we're going to work. I've gone ahead and circled the ones that will be needing logarithmic functions, but the rest we will not need. So let's talk a little bit about fractions. We should know that 5 to the negative 1st power is the same as 1 over 5. All right, so you'll still just find whatever you'll have to match the bases, but then you'll just have a negative exponent when it comes to a fraction. All right, so we have 25, which we can go ahead and rewrite as 5 squared, but we have 2x here is equal to, let's see, we have 5 to the negative 1, negative x plus 2. All right, I'm going to distribute and get rid of my bases at the same time. Negative times a negative will make a positive x. Minus 2 is equal to 4x. All right, I will move this x over. We get negative 2 is equal to 3x. Divide by 3. Divide by 3. Our x is negative 2/3 here. All right, let's move on to number 7. Or D, sorry. So we have, we have a couple different things here. So we can go ahead and say that we know that this is 10 to the negative 1, and then we also have x. But we need to look at this one here. So we have 10, the square root of 10 is also the same as 10 to the 1/2. All right, so we're going to go ahead and just convert the way that it's written. 10 to the 1/2, 6x minus 4. Luckily, everything we're cutting in half is even, so it's still going to look nice. All right, so then we have negative x is equal to, I've gone ahead and just got rid of the bases and I'm distributing, 3x minus 2. All right, if I were to move that 3x over, we would end up with negative 2 is equal to negative 4x. We actually end up with a pretty nice answer here. Negative 4, and our x is equal to 1/2. Okay. I'm just double checking my work here. Looks good, looks good, looks good. All right, let's go on to E. 9 and 35 don't share anything in common as far as their bases go. So we'll move this x to the front, and we're going to write log of 9 is equal to log of 35. All right, I'm going to go ahead and use my calculator to convert these numbers. But once we do that, it will also be the same as just dividing by log of 9, dividing by log of 9. So you'll take log of 35 and divide it by log of 9, and your x will be equal to 1.62. Okay, let's look at F. Same thing, we're going to have to move this to the front, so we have x plus 3 is equal to, or log of 15 is equal to log of 30. All right, I'm going to go ahead and convert these numbers. And then distribute at the same time. So once I distribute log of 15x plus 3 times log of 15 is equal to log of 30. I mean, you can change these to decimals and then distribute, or you can distribute and then change to decimals. It really won't matter. You can do these several different ways to get the same answer. Once I convert, I'll get 1.176x plus 3.528 is equal to log of 30, which is 1.477. I will subtract this. 3.528, subtract 3.528. And end up with 1.176x is equal to negative 2.051. Once I divide, running out of room, our x is going to be a negative 1.744. Okay? Sweet, let's look over here. Okay, so anytime we have E, hopefully by now you guys know that the only thing that cancels out E is going to be ln. All right, so we're going to have to use ln when we are solving these problems. Which one am I looking at? Okay, perfect. So what I'm going to do is multiply both sides by ln. All right, and when you plug in ln of 8, you'll get 2.079. Okay, ln times e, that means that those cancel out, and I'm left with 2x plus 1. Move this one over. I get 2x is equal to 1.079 divided by 2. X is equal to 0.5395. All right, we have one